Hello everyone. Hope you are all doing well. Welcome back again to our class Geography of Standard 9. Today we shall discuss about the motions of the earth, mainly the rotation and revolution. We shall concentrate on these four main questions. What is rotation? And we have to know also all the essential features about rotation. Then we also want to know about the Earth's axis, its effects, its different features. We should also know today about the circle of illumination, its definition, how it looks, what are its effects, etc. And finally, what are the major effects of the Earth's rotation. So now let us go straight in to highlight on the topic. Before we enter into detail about the rotation and revolution, let us be aware of one thing. It seems that sun rises and the sun sets. Yeah, we see the sun to rise in the morning, and then in the noon it is right at our upper head, above our head, and in the evening it seems to go down. We say the sun is setting, but actually it is the earth that moves. The earth moves on its own axis, due to which actually we get day and night, and the earth also moves around the sun. The sun is actually stationary and the earth moves around it. So on the basis of the two movements of the earth is moving on its own axis, we call it rotation, and the sun moving round the earth moving round the sun is known as revolution. So in detail, what is rotation? It is the spinning of the earth on its own axis. The axis has an angle of 23.5 degree from the perpendicular to the plane of the Earth's orbit. Here it is 23.5 degree. This is 23.5 degree. This is the Earth axis tilted. This is a straight line called the perpendicular. So from the perpendicular, the Earth axis is 23.5 degree. It means that the Earth is tilted on its axis, and because of this tilt, both the northern hemisphere as well as the southern hemisphere lean in a direction either away from or near to the sun. The rotation of the earth divides it into a lit up half, that means we call it a day, and a dark half, which ultimately gives us the night. Now there are some features that are associated with the rotation. The first thing we should know about the rotation is that it is the spinning of the earth around the sun. The time that it takes, it is 23 hours 56 minutes and 4 seconds. Little different that we know. We know that the earth takes 24 hours to go around, okay, and make a complete rotation. Yes, but in the geographical study we will see that the earth actually takes 23 hours 56 minutes and 4 seconds, little less, little around 4 minutes less. This time, this 23 hours 56 minutes and 4 seconds, in geography we call it a day. It is called the sidereal day. It has derived from the Latin word called sidus. Sidus Latin word means a star. So this is the star that is going round, and to make one complete rotation it makes 23 hours 50 seconds 4 seconds. However, if we consider the midday sun, then of course again we are back to our normal understanding that earth takes 24 hours to make one complete rotation. So there is a little confusion, no confusion. These 24 hours, it is called a normal day, whereas the 23 hours 56 minutes and 4 seconds, that is known as the sidereal day. Now there is a difference between a sidereal day and a day, around 4 minutes. Okay, now this 4 minutes difference comes due to the revolution of the earth. Remember, the earth is also going around the sun on its own elliptical orbit, which is called revolution. Now we have to know our earth axis is very unique. It is not straight. It is not straight. However, this axis is an imaginary line. It is drawn from north pole to south pole. It is drawn north pole. This is north pole and south pole. Okay, this is north pole and south pole. Although we can't feel the earth spinning, it makes one complete turn each day around its own axis. The earth takes 24 hours normal day, 24 hours, okay, to complete one rotation. The earth is tilted at 23.5 degrees from its perpendicular, just we have said, from to the elliptical plane. Now this path, this circle orbit, which is almost called parallel to the equator, this is called the plane of orbit. Okay, now from here the perpendicular, from here the perpendicular, so from here it is 23.5 degree. Otherwise from the orbit till the axis is 66.5 degree in the next point. The tilt of the earth is called the inclination of earth's axis. We ask you sometime, what do you understand by inclination of earth's axis? So the inclination of earth's axis actually means it is the tilt of the earth at the rate of 23.5 degree from the perpendicular to the elliptical plane. That you have to mention. If the earth was not tilted, what would happen? Then there would have always been one kind of season or same kind of temperature with constant duration of day and night throughout the world at the same time. So this tilt is very important, my dear. This tilt ultimately causes the summer, the winter, the autumn and the spring. Dear children, there is no rainy season in geography when you talk about the movement of the earth around the sun as well as on its own axis. The tilt or the inclination of the earth's axis always remains pointed at the same direction. Means if it is pointing at this direction, it will always be this at this direction. When you go and study about later about the seasons of, okay, in the seasons the position of the earth will be in different places around the sun, but all the time the tilt of the earth will be always pointing towards one direction, and that is towards the pole star. Now let us know about what is called the circle of illumination. Now suppose the sun is falling on one half of the earth. So one part, the earth can be divided into two parts. One half will be illuminated, means lighted. But from where? From where? Is it from the axis? No. It is not from the axis. See, this is not from the axis. See, Earth is tilted. The axis would have gone in this direction. You have got four examples. You have got four examples. Okay. Can you see? You have got four examples just in front of you. This is the axis. Can you see the axis? This is the axis. But the sun light is not divided in this way. In fact, if the sun is coming from this side, then this part of the earth is illuminated. Okay, you can clearly see there is a light part, day part is a night part. So this is the line that divides, that determines the day and night line. This line is known as the circle of illumination. You should be very, very clear in your mind that axis doesn't make the circle of illumination. Axis makes the center of the earth, whereas circle of illumination divides the earth into two parts, the day and the night. So this is the line that divides the one half of the earth into day part and the other half of the earth as night. So it is an imaginary line that separates light from the darkness and day from the night, is known as the circle of illumination. In short form, it is the line that separates day and night. The circle of illumination divides the earth in exactly two equal halves. The lighted part will be the day and the darkened part will be the night. The way that the earth turns, in relation to the circle of illumination, that determines the factor behind how many hours it is light and how many hours it is dark. The circle of illumination also plays a small part on determining the seasons too. The speed of rotation decreases as one goes away from the equator, because you know that the equator, the earth is bulging out, and therefore the diameter of the equator is much larger than the diameter if you go towards the pole. In the pole it is quite less. So the speed of the earth also, speed of the rotation also decreases as one goes away from the equator. That means at the equator the speed of the rotation is very high. We do not feel such a high speed or realize the fast movement of the earth, because you should know why. The earth is moving at such a high speed, but still we don't feel. It is almost like 60 kilometers per second, or 34 kilometers per second. It's very high speed, but still we don't feel or realize this speed. Why? It is all because everything on earth, including ourselves, are moving along with it. So therefore the speed of the earth is also along with us. We don't feel it. Once again, you can see this is the earth, and you can see the circle of illumination. This is circle of illumination. This is the axis. Do not get confused with axis. Axis doesn't make day and light line. It is a circle of illumination, days and night. This side sun is coming from this side, so this part will be day. This side sun is coming from this side, so this part will be day. The effects of the earth's rotation. Now due to this apparent movement, again we say apparent movement, why? Because the sun is not actually moving. What is moving is the earth. That's why we say the apparent movement of the sun The sun appears to rise in the east and set in the west every day. That is the effect of the rotation. Due to rotation, we get rising sun in the eastern side and the setting side in the western side. Obviously, occurrence of day and night in every 24 hours. And now the time difference of 4 minutes for 1 degree longitude is due to the rotation of the earth. If once move from, if the sun, if the earth is rotating, you remember the so many longitudes are there, and if it is rotating from this side to this side, and from say suppose it is 0 degree longitude to 1 degree longitude, so movement of 1 degree 0 degree to 1 degree takes 1 degree longitude, that takes 4 minutes of time. Rotation of the earth creates Coriolis forces. Coriolis force due to which winds get deflected towards the right in the northern hemisphere and to the left in the southern hemisphere. Coriolis we will be studying in detail in some other chapter too. But remember, Coriolis effect or Coriolis force is a very important effect of the rotation of the earth, due to which, suppose the earth is rotating. Now this is, you can cut the earth into two halves, the northern hemisphere, southern hemisphere. The movement varies in the ocean or in the wind, even in the ocean also. The wind seems to, suppose it is moving from this way to this side, no, but it will get deflected in the northern hemisphere, and in southern hemisphere it will get deflected to the left side. The occurrence of tides in the oceans twice a day, either twice high tide, twice low tide, also happens due to the rotation. And the earth got its shape as geode due to rotation, because it is because of the rotation the earth is bulged out at the equator and it is flattened at the poles. So with this we come to the end of today's lesson, dear children, and you will be given the homework on the basis of this lesson. Just three questions. What do you know about rotation and its effects? What do you know about the Earth's axis and its features? And finally, mention clearly the features of the circle of illumination. I remind you once again, dear children, these are the questions only for your homework. These are the questions only to understand today's lesson, but you have to study the whole chapter thoroughly, because the question comes from anywhere. So you will be ready to answer any question asked from this chapter. Till then, keep good health. Thank you.